When people asked Richard Feynman whether anything they did truly mattered, they were not asking a poetic question. They were confronting the emotional consequence of modern physics. Strip away mythology, religious centrality, and comforting cosmic narratives, and you are left with a picture of reality that is vast, cold, expanding, and indifferent. The Earth is not the center of existence. That illusion collapsed with Nicolaus Copernicus and was observationally reinforced by Galileo Galilei. Gravity unified the heavens and the earth under the mathematics of Isaac Newton, and later space-time itself bent under the equations of Albert Einstein. The discovery that the universe is expanding removed any lingering sense of cosmic stasis. Our planet circles an ordinary star located in an unremarkable region of the Milky Way, which itself is one galaxy among hundreds of billions. On cosmic scales, human civilization is thinner than dust on a window pane. On geological timescales, humanity occupies a fraction of a second. On thermodynamic timescales, even stars are temporary chemical reactions. Against this backdrop, asking whether your personal decisions matter appears almost naive. No law in Maxwell's equations references human purpose. The Schrödinger equation contains no variable for hope. The second law of thermodynamics does not pause for ambition. Entropy increases regardless of sentiment. The universe does not arrange itself to validate your existence. This realization feels like a verdict of insignificance, yet Feynman resisted that conclusion because it confuses scale with relevance. Physics does not grant importance by centrality, it reveals importance through interaction. At fundamental levels, nothing matters in isolation. A particle drifting alone through empty space has no observable significance until it interacts, exchanges energy, alters trajectory, or participates in a measurable event. Reality, as physics describes it, is a network of interactions unfolding according to lawful regularities. Causation is not narrative, but it is real. Every state of the universe emerges from prior states. Every event modifies what follows. When you speak, mechanical vibrations propagate through air. Electrical impulses cascade across neural networks. Synaptic weights shift. Memory reorganizes. Behavior adapts. None of this is mystical. It is physical consequence. The mistake is demanding that consequence extend to the edge of space-time in order to qualify as meaningful. If mattering means altering the fate of galaxies for eternity, then nothing matters. Not you, not civilizations, not even galaxies themselves, which will collide, decay, and disperse. But if mattering means altering what would otherwise occur within a system of interacting processes, then your actions qualify immediately. Remove a neuron and cognition shifts. Remove enough transistors and a computer fails. Remove a single decision and future events diverge. Physics is explicit. Outcomes depend on initial conditions, and you are part of those conditions. Feynman's intellectual discipline was brutal honesty, no comforting story unless evidence demanded it, but he also insisted that stripping illusion does not strip wonder. Understanding the molecular structure of a flower does not reduce its beauty. It reveals layers of organization invisible to casual perception. In the same way, understanding that you are an arrangement of atoms forged in stellar furnaces does not trivialize you. It situates you within a vast, continuous chain of physical transformation, stretching back to the earliest moments of cosmic history. You are not outside the universe observing it. You are a localized process within it. The question, therefore, shifts from a per se, did time I cosmically central, to do my interactions change subsequent states? The answer is unavoidably yes. Every choice modifies neural patterns, which modify behavior, which modifies environments, which influence other organisms embedded in the same thermodynamic web. These effects are not infinite, but they are measurable. They ripple across networks of living systems whose scale, while tiny relative to galaxies, is immense relative to human areas. The universe does not care in any anthropomorphic sense, but the systems within it respond. The indifference at cosmic scale does not cancel consequence at local scale. This is the essential clarity. Small is not synonymous with meaningless. The demand for infinite validation is a psychological projection, not a physical requirement. Physics offers no promise of eternal preservation, yet it guarantees continuity of cause and effect. Your existence, temporary though it may be, occupies coordinates in space-time where particular configurations unfold uniquely because you act. If those actions were absent, the configuration would differ. That difference is the operational definition of mattering within a lawful universe. Feynman would not decorate this conclusion with metaphysical exaggeration. He would simply point out that participation in causation is enough. You do not need to be the center of reality to influence it. You do not need permanence to have impact. The universe proceeds without regard to human narratives, but it does not proceed unchanged by human action. That distinction is subtle yet decisive. The cosmos is not a stage constructed for you, yet you are undeniably one of its dynamic processes, and processes alter trajectories. The scientific image of reality removes flattery but leaves responsibility intact. What you do will not echo forever, but it will alter what happens next. And in a universe defined entirely by successive events, altering what happens next is the only form of significance physics can honestly defend. It's a trouble probability. If part one removed humanity from the center of the universe, part two removes the illusion that the universe is a rigid machine running on an unchangeable script. Classical mechanics, crowned by the equations of Isaac Newton, once suggested a clockwork cosmos in which perfect knowledge of positions and velocities would allow perfect prediction of the future. This image implied that every event, including every human decision, was effectively predetermined from the beginning of time. Under such a view, asking whether your actions matter seems misplaced, because the future would unfold identically, regardless of your feeling of choice. Yet 20th century physics, reshaped profoundly by figures such as Albert Einstein, and later transformed at the microscopic scale by quantum theory developed and clarified by scientists, including Richard Feynman, fractured that mechanical certainty. At atomic scales, particles do not travel along single definite paths. They are described by probability amplitudes, mathematical constructs that encode multiple possible outcomes until interaction selects one. In quantum electrodynamics, a framework to which Feynman made decisive contributions, a particle effectively explores all possible routes between 2 points, and what manifests experimentally is the result of interference among these possibilities. The universe, at its smallest scales, is not a pre-written trajectory, but a structured field of probabilities continually resolved through interaction. This does not imply mystical free will outside physics, but it does eliminate the naive clockwork determinism that once dominated scientific imagination. The future is not a single inevitable line etched into space-time. It is a probabilistic unfolding, constrained by law, yet sensitive to conditions. You are one of those conditions. Every neural event in your brain is a cascade of electrochemical interactions built atop quantum processes and thermodynamic flows while governed by physical principles. These cascades participate in selecting among alternative states. When you decide to speak, remain silent, act generously, or withdraw. Billions of microscopic interactions occur, tipping a system toward one macroscopic outcome instead of another. Physics neither isolates you from law nor reduces you to irrelevance. It positions you as a node through which lawful probabilities become actual events. Now add thermodynamics to the picture. The second law states that entropy, the measure of multiplicity or disorder, tends to increase in closed systems. Ice melts, gases diffuse. Stars exhaust fuel, large-scale structures move toward more statistically probable configurations. This principle introduces the arrow of time and ensures that complexity is fragile. If everything trends toward equilibrium, then human structures, biological, cultural, psychological, appear temporary rebellions against statistical inevitability. Yet entropy is statistical, not prohibitive. Local decreases in entropy are not forbidden. They are simply paid for by greater increases elsewhere. Life itself is a thermodynamic phenomenon in which organized systems maintain structure by importing energy and exporting disorder. You are a dynamically sustained island of low entropy, constantly exchanging matter and energy with your environment. Your brain's structured activity, memory formation, conceptual reasoning, anticipation exists because energy flows maintain gradients far from equilibrium. Within these gradients, small variations can redirect large cascades. A single decision shifts neural patterns, which shift muscular movement, which alters social interaction, which modifies environments and future options. None of these processes violate the second law, they operate within it, channeling energy through organized complexity. Entropy guarantees eventual dissolution, but it does not negate interim influence. The common error is to assume that because heat death looms billions of years in the future, nothing occurring now has value. By that logic, any finite structure would be meaningless, including stars whose fusion processes forge heavy elements for billions of years before extinguishing. Transience does not equal triviality. It defines the condition under which structure operates. Duration is not the metric of physical consequence. Systems can dominate epochs without existing eternally. Human civilizations, though brief in cosmic time, reorganize planetary chemistry, redistribute energy, alter evolutionary trajectories. These are measurable thermodynamic events. The universe may not attach narrative weight to them, but it registers them as physical transformations. To say that nothing matters because everything eventually ends is to misunderstand what matter means in a causal framework. In physics, mattering equates to influence, altering subsequent states in ways that would not occur otherwise. because outcomes depend on prior configurations, and because your behavior is part of those configurations. Your actions are woven into the chain of causation. Even in a probabilistic quantum universe, probabilities shift according to conditions. Even in a thermodynamic cosmos trending toward equilibrium, pathways to that equilibrium differ based on intermediate structures. You are one such structure. Remove it, and trajectories change. This is not sentimental philosophy, it is systems analysis. Feynman consistently rejected appeals to comforting cosmic narratives. Yet he also rejected the premature slide into nihilism. He emphasized intellectual humility, the willingness to say I don't know without surrendering to despair. The laws of physics neither exalt nor dismiss human life. They describe frameworks within which life emerges, persists, and acts. When you act, you modify local entropy flows, redistribute energy, and influence probabilistic outcomes in surrounding networks. These influences may not scale to galaxies, but scale is irrelevant to the definition of causal efficacy. A transistor in a microprocessor does not shape the cosmos, yet its state can determine whether a computation succeeds or fails. A neuron in a cortex does not alter the expansion rate of the universe, yet its firing can alter a decision that reshapes communities. Physics operates across hierarchies of scale, and significance is contextual within each hierarchy. If your standard for meaning demands permanence across cosmic infinity, physics offers none. If your standard is participation in lawful transformation, physics confirms it unequivocally. The universe is indifferent in the sense that it contains no encoded preference for your happiness, but it is not indifferent to initial conditions. Causation is strict, change is cumulative. You exist as a thermodynamically sustained, probabilistically sensitive system embedded in a network of other such systems. Within that embedded structure, every action narrows possibilities into actualities. That narrowing is real. That alteration of what happens next is what mattering means in a scientific cosmos. Consciousness, emergence, and the generation of meaning. By the time modern physics has stripped away cosmic centrality and mechanical determinism, one element remains stubbornly present.
Consciousness. The universe described by equations governing space-time, quantum amplitudes, and thermodynamic gradients has, through lawful evolution, produced systems capable of awareness.
Among those systems are human brains, biological structures of extraordinary complexity operating entirely within physical law, yet capable of modeling reality, anticipating futures, and assigning value. Richard Feynman insisted that there is nothing outside nature. Thoughts, emotions, and intentions are not exceptions to physics, but consequences of it. Roughly 86 billion neurons exchange signals through electrochemical gradients, ionic flows create voltage differences, synaptic weights encode memory through structural modification. No ghost inhabits the system, yet the system generates experience. At the level of particles, there is no meaning. Electrons do not deliberate. Photons do not hope. Meaning emerges at higher orders of organization, just as temperature emerges from molecular motion and a whirlpool emerges from fluid flow. Emergence does not introduce magic. It describes collective behavior irreducible to single constituents despite being fully dependent on them. Consciousness is such a collective behavior, a pattern sustained by energy throughput and structural feedback. Within that pattern arises the ability to simulate alternatives. This capacity to represent what is not yet actual is central to meaning. A rock rolling downhill does not prefer one trajectory over another. A conscious system can imagine consequences and assign weight to them. Preference is the operational core of meaning. When a brain evaluates potential futures, social approval versus rejection, safety versus danger, cooperation versus aggression, it performs physical computations whose outcomes redirect behavior. These redirections alter external conditions which feed back into other conscious systems. Meaning, therefore, is not etched into space-time as a universal constant. It is generated within networks that can model and respond to consequence. The universe did not begin with purpose embedded in its equations, but over billions of years of cosmic expansion, stellar fusion, planetary formation, and biological evolution, matter organized into structures capable of reflection. In that limited but astonishing sense, the cosmos has produced localized regions where it becomes aware of its own dynamics. When you contemplate gravity or quantum mechanics, the same universe once described by Albert Einstein and explored experimentally across generations is examining itself through your neural circuitry. This does not grant humanity metaphysical privilege. It demonstrates that self-referential complexity is physically permissible. Identity under this lens is not permanence of substance, but continuity of pattern. The atoms composing your brain are gradually replaced through metabolic exchange, yet the organizational structure of synaptic connectivity maintains a trajectory of memory and personality. You are a temporally extended process, not a static object. Thermodynamics guarantees that this process will not persist indefinitely. Entropy erodes gradients, systems lose integrity, patterns dissolve. But impermanence does not negate actuality while the pattern exists. A symphony concludes, yet during its duration it shapes emotional and neural states, and listeners, those states may propagate further, influencing choices and environments. Meaning operates in this intermediate regime between instantaneous fluctuations and cosmic eternity, where organized patterns interact. The demand that significance require infinite duration is a psychological projection rather than a scientific necessity. Galaxies themselves merge and dissipate. Even massive structures are transient against cosmological timescales. If impermanence invalidated importance, no structure in the universe would qualify. Instead, physics frames significance through causal participation. Conscious systems amplify this participation because they incorporate symbolic representation. Language encodes information, information reconfigures other brains, and collective cognition reorganizes societies and ecosystems. These are cascades of lawful cause and effect operating within thermodynamic constraints. Freedom, viewed scientifically, does not mean exemption from law, but the capacity of a system to evaluate internal representations and act according to them. Neural networks simulate possible futures, biochemical processes, weight outcomes, motor outputs, implement decisions. Though influenced by genetics and environment, these processes are uniquely configured in each individual, ensuring divergence in action paths. Each choice collapses a set of modeled alternatives into one realized branch of events. Remove the chooser and the branch differs. That divergence is measurable at local scales, and through amplification across networks can scale dramatically within human systems. The universe does not encode ultimate purpose, but it encodes lawful responsiveness to conditions. Consciousness is one such condition-generating structure. The persistent confusion arises from conflating cosmic indifference with causal emptiness. Indifference means the laws of physics contain no clause privileging human narratives. It does not mean events fail to influence subsequent states. Your existence occupies coordinates in space-time that serve as input variables in the evolution of surrounding systems. Physics guarantees that different inputs yield different outputs. Therefore, the presence or absence of your decisions modifies trajectories. Feynman's intellectual honesty would forbid inflating that modification into eternal destiny, yet it equally forbids dismissing it as nothing. You are neither the axis of the universe nor a negligible speck without consequence. You are a dynamic configuration embedded in a vast network of dynamic configurations. Meaning, under rigorous analysis, is the experiential register of causal efficacy within conscious systems. It arises when interactions affect modeled futures that organisms care about. Care itself is a biological adaptation rooted in survival and social coordination, but its experiential reality is undeniable. Because it shapes behavior and environment, entropy will dissolve all organized complexity, stars will exhaust fuel, galaxies will thin, and heat death will erase structure. Yet this distant fate does not retroactively nullify intermediate transformations. Physics operates moment by moment, state by state. In each transition, local configurations matter to subsequent configurations. You participate in those transitions now. The universe offers no guarantee of permanence, no external validation of worth, but it does provide an unbroken chain of cause and effect within which your actions function as variables. That is the full, unsentimental answer. What you do does not matter to the universe as a narrative entity, yet it matters within the universe as a causal process. You are a temporary, self-aware arrangement of matter capable of modeling and altering futures. In a cosmos defined entirely by interactions unfolding across time, the ability to alter what happens next is the only defensible definition of mattering, and by that definition, your actions undeniably count.